This is Module 10, Lesson 2. It's now time to start looking at circuit diagrams. We've been talking about moving charge, so moving charge has to have a path to flow through. That path is called a circuit. So, like I just said, a circuit is a path where electricity can flow. We're going to be interpreting a lot of these diagrams, so we're going to need some things to work with. What I have here is a table on your paper where you're going to fill it in as we do it. When we draw circuits, we're going to use several pictures, and I'll give you the name and their function. As far as the first thing goes, the way that we would do the first thing, it would look like this. When you see this in a circuit, this is your switch. It's like a light switch. And what it does is it stops the flow of electricity. And we could put start, kind of. It stops or starts the flow of, I just put electrons, but electricity. If it's open, and this is specifically an open switch, then it is going to stop the flow of electricity. If we draw it this way, and we connect the two dots, then that is a closed switch. And what it does is it starts the flow of electricity. My chicken scratch is really bad this morning. I should have typed all this in there. Okay, another symbol that you'll see looks like this. That is the symbol of a light bulb. And I think we all know what a light bulb does. It gives off light. End of story. Sometimes you'll see a little A in a circle. And when you see that, that is called an ammeter. And what an ammeter does is it measures current. It measures amps. Okay? So lots of times you'll have the circle and it'll tell you inside the circle like 2 amps or 3 amps. And what you have is an ammeter. Similarly, if we have a V inside of a circle, that is a voltmeter. And what does it do? Of course, it measures voltage. End of story. It tells us how many volts we have. Alright, a funny looking symbol that we have looks like this. Something to that effect. Looks like a zigzag. That is a resistor. And what resistors do is they slow the current. They create resistance and they make it just simply slow it down. Okay. You'll also see this symbol. Now, and it's a battery. It's specifically a short line and a long line. That battery that I just drew is a 1-cell battery. I'll draw it over here. If you saw this, then you have 2 cells. If you saw this, then you have 3 cells. So basically that's telling you that you have like 3 batteries together. So short, long is 1 cell. And what batteries do, remember, is they create voltage or a potential difference. Without the battery, you have nothing. And I probably should have done this one first, but every time you see these lines, that's simply the wire. And what the wire does is it makes a path for electricity to flow. So these are our basic ingredients of creating currents. Part of what you're going to be doing for this practice assignment is drawing some circuits. We're going to draw some together for just a minute to make sure that you understand how to draw them and then how to interpret them. So here we go. We have some definitions while we do some drawing. The first one is the definition of a series circuit. Well, we have 2 different types of circuit, and series is the first. In a series circuit, there is only one path for electricity to flow. Now, here's the thing about having one path for electricity to flow. If you have one path, it's like having one path with your pipes. Like if water has to flow through something, when you have one path, that means you have to go through every single thing that is there to get back to where you started from. And if the path gets blocked, then everything gets blocked. Then you have no flow. So let's draw a battery of 2 cells. So here's our 2 cells. One, like short, long. There's 2 cells connected to 2 resistors in series. Well, there's multiple ways that I could draw this. I'm going to work off of squares. So there's one resistor, and here's another resistor. For the sake of this lesson, I'm going to draw this a couple different ways, just to make sure that you understand. I could have drawn the one on the left or the one on the right. Both of those have two resistors in series. We could get all fancy and draw a circle. You know, nobody says that it has to be a square. I mean, all of these are showing resistors in series, so you get the idea. How you know it's in series is if you put your finger on it right here at the battery and you had to make a complete loop to get back to the battery again. The only way that I can go is this path that's laid out for me. Whether it's a circle, a rectangle, or whatever, that is a series circuit. There's only one path for the electricity to flow. If you came in here with a big pair of scissors and you opted to break this circuit, oops, I just meant to erase part of it, but I erased all of it, so let's just do this. You break it right there, and you break your circuit apart, and you make a hole in it. What's going to happen now is that the electricity is no longer going to flow. If you have the broken circuit, you could put a switch in there, like this, and you could open and close it, and when it's open, no electricity. As soon as you close it, electricity flows. Okay, broken circuit means nothing happens in series. Then you have parallel circuits. Parallel have more than one path for electricity to flow. So this is draw a battery of two cells connected to two resistors in parallel. So here's our two cells again, 1, 2. And I'm going to square this up. I'm going to put one of them here and one of them here. These are in parallel with each other. Why this is called parallel is because there are two paths that the electricity could take. I'll do the first one in a lighter blue. We start out up here, the electricity can come down here, and then it has a choice. It can go through this one and wrap back around to the top one. But what if this one gets broken? Well, then not a problem, because the electricity can still flow out of there, and then it can go the bottom route, and it can go all the way back around. It has two different paths that it can go, path 1 and path 2. Now, you could do this and do it wrong. Watch this. If I put my first resistor here, and then my second resistor here, and I make a loop like that, my resistors are not wired in parallel. These resistors are wired in series. How do I know? Put your pin on it or your finger, start it out at the battery, and go through both of them. Like, go through this first one, and then make a loop to get back. I can go through just one, like that. But in order to get through this one, I have no choice but to go through both of them. You see what I'm doing? Like, I have to go through both of them to get back to the battery if I'm going through the second resistor. So that is in series. You can actually have things that are wired both ways. And I've lost track of my lightly colored, there we go, my lightly colored cursor. Here's an example to show you some more. If I do this circuit here that we had before, and we put a third resistor in it, then we have two things going on. We have series and parallel going on. If I use, let's use green, maybe I won't lose it as bad. If I start out at the top and I go through the first resistor and the second resistor and go back to the battery, these two resistors, we'll call it R1 and R2. These two resistors are in series with each other. But R2 is in parallel to R3. R1 also happens to be in series with R3. I'll switch colors here. Let's switch to red. Okay, if I start out at the battery and I go through resistor 1, I have to go through 1 to get to 3 as well. Don't know what just happened right there, but it went away. So, as you can see, R1 and R2 are in series. R1 and R3 are in series, but R2 and R3 are in parallel. This is a more complex circuit because we can have those two. You guys need to be able to interpret what you're looking at and understand how things are wired together. Now, what happens in parallel if you end up with a break in something? Well, if you ended up with a break, let's just say right here, We come in and we take a pair of scissors and we cut through the wire right here at this particular place. Well, then what's going to happen is that R2 is going to be out of commission. But you see my red path? It can keep going because there's still an alternate path for the electricity to take. It can go through R3. Now, what if I broke it, we'll do it in darker blue. What if I broke it right here at the blue X? We break our line right there. Well, then in that case, nothing is going to happen because we've cut the flow off before it can ever get through any of the resistors. There's no path for it to take. One little note before you're going to draw some on your own is that there are two different types of current. You have AC and DC. I'm sure you've heard of them. I'm not talking about the band. DC stands for direct current. It flows literally in one direction. Alternating current actually alternates back and forth, like in a kind of like a vibration type thing. DC is what comes out of batteries, whereas AC is what comes out of your electrical outlets. AC is used because it increases how far electricity can travel. So if you think about it, our closest power company that I'm aware of is our electricity that's being made is being made mostly from Marshall Steam Station or from hydroelectric power on Oxford Dam. And from those, like, it's got to travel a pretty good little ways to get across our county and make its way to your house. And so if they did it direct current, it would never make it there. So they use alternating current to send it over that many, many miles that it takes to get to your location. You have converters on a lot of things, if you've ever noticed it, that switch things from AC to DC. If you have something that works off of batteries, then most likely it's got the little power pack, you know, like you go plug it in your wall, and it's got the little thing, you know, that you plug in your cords attached to it. It's got the big box on the end. It's not just a regular little outlet. It has a little outlet plug. There's two things going on in there. One of them is probably a transformer, which we'll talk about in Module 11. And then the other thing is it's probably got a converter that's switching it from AC down to DC so that it doesn't ruin your appliance. So now it's practice time. What you're going to be doing during practice is just drawing your circuits. Remember that there's going to be multiple ways to draw them. I'm not giving you an answer key, but I'll check your drawings when you turn them in to me to make sure that you have things in the proper places. If you need help, feel free to let me know.